Hello and welcome to my write-up of K2 Basecamp from TryHackMe. So K2 Basecamp is the first installment of a series of 3 machines that are all linked together via information. So information gathering from one machine will help with steps in another machine further on. K2 Basecamp first starts with a cross-site request forgery vulnerability that allows you to steal an administrator cookie. From there, you gain access to a search function in which is vulnerable to SQL injection. Then you can conduct union injection and then get the password and usernames from the database. From there, brute force SSH, gain access to the server, and then find credentials in the web application log. So first thing I'm going to do is run an nmap scan. So nmap ccv-v-5. So port 80 and 22 are open. These are the only ports open on the machine, and the only port we're interested in is port 80, unless port 22 is vulnerable to some sort of CVE, or potentially in a network it's got an older version of encryption you may be able to decrypt. Apart from that, we only care about port 80. What I'm going to do is visit this on a website. And I've just got Burb open on the side. You can see here, it's a static website. Nothing, you can't input anything. This contact form will just go to the hashtag. So it just won't go anywhere. No directories, nothing. It's important to note that in the challenge details, they actually give you the domain name, or not the domain name, the virtual host for the application, and that is k2.thm, and we'll just edit that with such and such. And you can see here we have added it, and let's go to K2 try. So this site is still the same. Since we didn't have access to any directories or interesting web application functionality, I was prompted to fuzz for virtual hosts, meaning that I would send requests to a bunch of different strings appended to k2.tryhackme to see if any of them resolve or any of them don't send an error back. And we can do this with GoBuster. I'll just get up GoBuster. This command here, GoBuster vhost-u k2.tryhackme wordless user share discovery subdomains, and then --add. So that --add adds the string from this word list to the front of K2. If you didn't specify --add, it would just fuzz for just a string, HTTP just a string. But since we add --add, it adds it to the front of K2.tryhackme, which is what we want. And you can see here it comes back with 2 endpoints. Not 2 endpoints, 2 virtual hosts. So essentially what this is that the machine maps these different domain names to different web application services. That's essentially what's happening. And we can add that via our Etsy host. You can see here I've already added it to the IP. Editing the Etsy host just points a domain name to an IP for our host. So the Etsy host file is the first location that the system will check to resolve domain names. And let's just go to it.k2, do admin. So admin IT ticket view, we need a username and password, and log into IT ticket system. Username, password, sign up. Let's sign up here. Agree. And we've logged into the system. You can see it seems to be a ticket. Well, it is a ticket submission. Takes a title and a description. Another thing to note is the admin. the admin virtual host. This seems to be a viewer, an IT ticket viewer. So an admin is viewing the ticket. We are sending the ticket. This is a classic cross-site request forgery vulnerability or cross-site request forgery scenario. And essentially what we're going to do is exploit a cross-site scripting vulnerability in this admin IT ticket view to get the administrator cookie. However, there is a web application firewall, not a traditional web application firewall. It's not intercepting the packets or doing deep packet inspection. It's merely just server-side code. But you could probably classify that as a web application firewall. So what I'm going to do is attempt some cross-site scripting. So we can see here, script, and we'll just do alert and we'll submit it. Ticket submitted successfully. It will be reviewed shortly. So this isn't flagged any web application firewall. However, what does flag the web application firewall is document.cookie. This is a very poorly implemented web application firewall, which would have to be obviously purposely made for this this room, because no one's making something like this. It's essentially a blacklist that only denies document.cookie. It's not doing any code analysis or anything really. It's not blocking any HTML characters like the dash or script, or it's not a whitelist that only allows A, B, C, D, E, F, G all the way to Z. It's just poor form. However, we can bypass this. So the way we get a cookie is as follows, or a traditional a traditional XSS looks something like this. So image source equals 1, which doesn't exist, and then on error, this error will be caused because the image source doesn't exist. We're going to move our location to our attacker IP and send document.cookie to the log endpoint. What this is doing, sending the document cookie of whoever clicks it, or whoever renders this HTML, it's sending the document cookie to this endpoint, which we control. However, how would we do this if we can't submit document.cookie? This is where the document object comes into play. So essentially, document is an object that has accessible values inside of it. So it's much like a Python class where you can call the functions from inside of it or reference values from inside of the class. We can do the same without having to supply the word cookie. What we can do is this right here. So we're creating a script. We're setting a variable of cookie. So this is split up by individual characters, and the word cookie is not in any of this code all condensed, so it's not going to trigger the web application firewall blocking the document .cookie. And we're just redirecting the user to our endpoint and then doing document and in straight brackets fn. So we're doing document with cookie inside. So we're referencing the cookie value from the document object. And this will work. Before we do that, let's just set up a listener here. And send it over. We're just going to send it in both the title and description. Maybe one isn't getting rendered, the other is getting rendered. If we wanted to test this payload, we could create a HTML file on our own web server, and then click on the HTML file and see if it redirects us and see if it gives us our cookie. But in this case, it was pretty quick. Sometimes when I was originally doing this, it took maybe 30 seconds, minute. This was quite quick. We must have got it right on the cron job timer. But yeah, we have the administrator cookie here, and that cookie is called session, so that's useful to know. And now we'll go to the admin site, which is just here, and we'll create a cookie. Just make that bigger. Storage, admin session. Let's just remove this. Create a cookie. We're going to call it session and set it to the value of that. Cookie sent to our endpoint. And then that will be rendered. Another thing to notice is the HTTP only. HTTP only is means that if it's set to true, only HTTP can access this cookie. Meaning that JavaScript can't reference the cookie with documents.cookie. So if this web administrator had set this HTTP only to true, then we wouldn't be able to get the cookie via cross-site scripting. But that's set, and what we're going to notice is we'll get Control R, doesn't work. This is because assuming there isn't any like session management for this page. It's not checking for cookies and then checking if the cookie's authenticated on this index.html file. So it's not going to redirect us anywhere. It's not going to notice we're authenticated. What we're going to have to do is go to the dashboard. And this endpoint does check our cookie and test to see if we're authenticated. Can't see it here, but in our request, it would be taking in our cookie and validating it. For example, I'll just change the cookie ever so slightly. Let's get rid of half of it. If we were to go to dashboard again, it would not work. So that's checking our cookie, but the other, the index.html endpoint is not. What the hell? Take a review. Okay, we have 3 columns that have title, user, and description. From here, we could assume there's a user Smokey, Hazel, Paco, and Jenny. We could potentially brute force for passwords, but considering that there's multiple users, I don't think that's the way to go. If there was one user and I was really stuck, I'd consider brute forcing, but 4 users, the key space is extremely large, so most likely not the option. But select ticket title. This is a classic kind of database response. I'm assuming they store the ticketing system inside of a database instead of making files or something in like the web directory. And this is vulnerable to SQL injection. Sorry, and we can test for that with either a valid or invalid query. So we'll just cause an error here. That completed the string. Sorry, we need to cause an error. So that response was a valid SQL query, so it didn't cause an error. That's also a valid SQL query. Maybe a single quote, and yeah, that bugs it. That is because we're injecting into a query with single quotes. For example, I'll show up here. I'm assuming the query looks like this. Select all from tickets where title like or actually title, yeah, like such and such. So we're injecting into single quotes. If we put a double quote in here, still a valid query. If we put a single quote, there is a quote that's left unclosed, and that's going to cause an error. If we put this in, it's also not going. It's going to cause an error. So now we've got an idea of what that query looks like. We can do whatever we want. We could send. We could try and do a union injection. And what this union injection is going to do is output more information. So this command is what, for example, is being ran when you enter. This is the SQL statement. And what a union select statement allows us to do is append the result of another query into the same response. So select all tickets where title like this. This is going to give us a response of 3 columns. If we do a union select, we can get more data and then put it into the response of 3 columns. So it will return information from multiple queries in the same result. And that's essentially what we're going to do. So that allows us to query other parts of the database, such as the username and password of an administrator, and include it in the response of this original command. And what that's going to look like is the following. So we're just going to search for nothing because we don't want anything up. Select all from tickets where title like bang. And then we're going to do union select null. And you're going to notice something will happen. That doesn't make sense. I got that query wrong. Oh, I've copied the full query. That's my fault. Just copy this. Yeah, and you'll see it errors out. This is because if we do a regular search here, the response is 3 columns, 1, 2, and 3. And remember what I was saying about the union injection, where it appends the results of another query into the same response. It needs to match 3 columns. So this union select has to match 3 columns of results, and we've only supplied 2, and it's going to error. But if we do another null, this will successfully work. Oh, oops, copy it all again. No. This will work. And you can see here, null. So this is valid SQL injection, and we can union inject. Now, what do we want? Let's say we want the user and version of the database. These are MySQL commands or MySQL functions. You could do an assortment of actions to fingerprint the database, but by process of elimination, I found out this was MySQL. And yeah, James at localhost is a user running this database or connecting to this database, and this seems to be the version of the operating system, or maybe the version of the MySQL service running. But it looks like the operating system version to me. But that's useful information. Keep in mind the James at localhost here. Now we want to look for the username and passwords we can dump from this database. We know for a fact there's usernames and passwords on this database because the ticket system made us log in and the administrator system made us log in. So those passwords are being stored somewhere. Sure, definitely not plain text, or they're definitely not appending it to a file or something like that. They'd just be using a database. However, how do we get that information from the database if we don't know what the database is called? So we want to go select username and password from administrator, from the table administrator. However, we don't know where do we take the username and password from. This is where the information schema comes into play. So the information scheme is essentially settings, a database of settings and configuration that maps the database and has information such as permissions and users allowed and the names of tables, the names of columns, etc. And we can query this to find out the name of all the tables on the database. What we'll do here is just that. Do new union select table name null from information schema tables. And that gives us all the tables on the database. I'm assuming these are all part of the information schema itself. These are all tables inside of the information schema. Let's see here, yeah. Yeah. And admin auth looks good. So there's a table called admin auth users, and tickets. Admin auth looks the most high priority to me. So let's look at that. However, what do we get from that? How do we know what the column names are? Select what from admin auth? We don't know what it is. We can also use the information schema to find this. So union select column name information schema dot columns columns where table name equals admin username, admin password, and email. So these are and ID. So these are the column names from the admin auth database. So now we can just get that information. So select admin username, admin password, and email from admin auth. So now we've successfully enumerated the database to give us the table and column names to where we can dump the database contents. And we have a list of usernames, passwords, emails. We're only interested in the names and passwords for this machine. And first thing that catches my eye when I did this was James. So we had already found the user on this machine, which was James. So I know for a fact this user is on the machine, and I just immediately tested the password and it worked. However, I always put the username and password in separate word lists and just brute force every endpoint when I get a new password, when I get a new user, to see if anything sticks. So this is a super prevalent ideology that I use in Active Directory, as password reuse is a very common vector. So let's just go back here. I have created a list of passwords and a list of users. I've only included rows root. Actually, we'll put the user here. With this, just James here. I'm not going to waste time running through all the other users because I know they don't work. But Hydra user pass SSH on K2, and yeah, James with this password. So let's log on here, SSH K2, and the password. Let's increase the size a bit. One thing I notice is that the what's it called? It's the web application is running in the user's home directory. Here you can see the admin site is actually running in the user's home directory, and the ticket site is running in the user's home directory. So it's a little unusual, I guess, but can't really see why it's any different to having it in a the web directory of var www. The only thing I notice is it's not running as www data. This means that the web application is running in a higher privileged user environment, um, which has actually has a shell. With www data, you can't SSH, unless specifically configured. But this is a bad security practice. You always want the web application running in the lowest possible privilege you could possibly have, and anything running lowest possible privilege, in every situation. If we were www data user, this would be a completely different attack and probably would not work. I would go through my typical enumeration steps. I'd go cron jobs, any processes running, database, leftover database credentials, hard-coded credentials in the files, tasks, what else, other networks, IP, services running, localhost, stuff like that. Checked all that, going through my list, group UID, set UID, files I can read, files I can write, stuff like that. Going through the checklist, I found username and password in the logs of the web application, and accessing the logs of a web application is always good. Not just accessing logs of the web application, but accessing the logs of everything on the system. So sudo logs and access logs and error logs and stuff like that. It gives you a great idea on the system. And when I do challenges that may involve an LFI, the audit log, the logs is one of the first things I check, because it can have a bounty of information inside of it and give you access to endpoints you don't know about, directories you don't know about, potential credentials pass, variables pass, API endpoints, all that good stuff. And it's just a treasure trove of information. So we'll just go to var log. And we'll go, just for example, a cat auth dog log to show. This just shows user James logs in. I think this may just be us logging in. Yeah, this is just traffic from us. But if this was a system, we may have other users that may have logged in. We could see other users on the system. If it was an LFI, that may be handy. Fail log, syslog. Let's look at syslog. Everything running. You see here, cron jobs. I've seen SSH keys in here, services that start up, configuration locations of services, just great. Great stuff. You can see here, cron job running every minute. And I'm assuming this is the cron job that clicks links for the cross-site request forgery. But let's just get to it. We'll go to the directory nginx. Oops. And we'll just cat the access log. This is going to have all the requests sent to the web application, or all the web applications at that, and this is going to be a very large file, as you can see. This is because it's essentially every request, including all of our GoBuster requests, Nmap requests. Nmap will do some fingerprinting at the top here. I wonder if we can see it. I may have cancelled the Nmap scan before it sent out its fingerprinting request, but yeah, the GoBuster request for the virtual host fuzzing, stuff like that. Very large file, but also great information. And what we're interested in is access level 1. This contains a log file that isn't actually updated. I'm assuming they've done this, so it's just not overcrowded with information. However, if you were to use grep, you'd be able to find it sweet and easy anyway. But you can see here login for the user and password of rows, and this is to the admin virtual host. So I'll copy this over into our file here. And here it is. And we'll vim users, we'll put rows in here. And root. This aspect of the challenge really highlighted, for me at least, credential reuse really highlighted the fact of creating user lists. Like, it put even more importance when it's already so important. There's really nothing to lose by literally brute forcing everything, every password against every user on every endpoint. Obviously, apart from the fact if it's any sort of real environment, you just lock out accounts and just make anyone running the SOC really pissed off. It's not very sneaky. Any like tools, Hydra, they're all fingerprinted. They all send user agents over, and send their own banners, etc. So yeah, but it's important to just fuzz and brute force all passwords. As you'd think, you'd see username rows, password rows. Why don't we just su as rows? However, or switch user as rows. This is not going to work because this password is actually for the root user, and the only way you're going to discover that is by brute forcing or manually checking. To me, I didn't actually manually check because I don't know, like, why would I put the password for another user as for root? It doesn't make any sense. But that's why password fuzzing or password brute forcing is great. We'll just do Hydra. And then we're going to James user. Maybe root in a couple seconds. Okay, here, root. This is the password for root. So this is the machine fully completed. However, in the K2 room, it has a couple more answers we need to send, like what are the usernames and passwords that had access to the server, and what are the full names of the users on the server. So this is information that they've purposely wanted you to collect to remember for the next machine in the series. So information I just stated will be used to gain access, gain a foothold in the other systems. I'll just show you quickly how we found the full names. So we can do cat / the password. You can see here Rosebud and James Bold. That's in I think the description segment of the Etsy password file. But yeah, that's that and the password. Yep. What are the usernames and passwords that had access to the server? I'm just looking at the questions in the other monitor. Let's see here. We know the James password, which is this. We know the root password, which is this. However, how do we get the Rose password? What I'm going to do is potentially check the database here. MySQL. Maybe it's something stored on that database. Password. I'll just go to the web application here. Site. We should get some sort of configuration. James password. Yeah, here's the Here's the Rose password. It was just in the results of the web application. But yeah, this is the Rose password, this is the James password, and the root password is obviously the password we just discovered, which is this. So that answers question 3, and question 4 is James Bold and Rose Bud, which we found in the Etsy password description. Thank you guys for watching. I'm going to post the step 2 shortly. And see ya.